dear students. As I told you in a new lecture, we will talk about amphoteric compounds. What are the amphoteric compounds, or what is the amphoteric property? It's better to explaining amphoteric things. Okay? What is the amphoteric property? Amphoteric property, it means double reaction. Double reaction. How double reaction, teacher? We have some compound that can release a proton when they meet a base compound, and we have some the same compound that can accept a proton if they see the acid. So it means we have both properties in the same compound at the same time. Okay? If they react with the acid, they become base. If they react with the base, they become acid. We have two types of amphoteric chemicals. It's better for describing that thing. We have amphoteric compounds and we have amphoteric ions. Very good. Okay. Amphoteric compounds, any species that can react as either acid or base, such as CrOH by 3, AlOH by 3, and H2O also. H2O is an amphoteric compound because we have seen that H2O reacted with the acids to be a base and reacted with the bases to be acid. Oh, now I understand why we get water as an acid in some reaction and as a base in some other reactions. Because of water is an amphoteric compound, it can release or it can gain a proton. Because of their neutral, zero charged, so they are amphoteric compounds. Amphoteric compounds, they are neutral molecule. Please don't forget that. It's very important. And again, we have amphoteric ions. Amphoteric ions. We have amphoteric ions. So it means we have something that can receive or lose a proton, but they are charged. So they're going to be amphoteric ions. Amphoteric ions, ions that can receive or gain a proton in a proper reaction. So we have two types of amphoteric compounds and amphoteric ions. Amphoteric compounds are neutral, amphoteric ions are charged, mostly negatively charged. Well, I prefer to give you some details about amphoteric ions. Well, I'll start by the ionization reaction for the polyprotic ions. For example, we get H3PO4. Then it can produce H2PO4, negative one. It can produce HPO4, negative 2. And it can produce PO4, negative 3. Okay. Look. Is that amphoteric? No. It can release a proton only. It cannot gain a proton. So it's not amphoteric. About H2PO4. Teacher, H2PO4 can lose another proton, okay, minus proton, to producing HPO4 negative 2, and it can gain a proton to be back as an acid. So it can gain and it can release. So it will be amphoteric ion. What about HPO4? Well, HPO4 is the same case as in here. It can gain a proton to be H2PO4, and it can release a proton, or it can donate. It can give up its proton to producing PO4. So it's amphoteric ion also. About PO4, no, it has no any proton at all. So the only potential for PO4 is gaining a proton. It cannot release a proton because of it doesn't have any proton. So it's not amphoteric. Now we understand that when we have a polyprotic acids and after releasing the first proton or remaining a proton in the polyprotic acids, when they become the anion, so it will be a polyprotic, it will be a ionic amphoteric or amphoteric ion. Let's see. HSO3, it can return back to H2SO4, H2SO3 or SO3, gaining or releasing a proton. So it's amphoteric, amphoteric, amphoteric. We know that. It's very easy. But there's a condition for these things to be amphoteric. They should present out of the reaction. It means if we have these compounds out of the reaction, if they present without the reaction, they are amphoteric. But if we put each of them in the reaction, they don't. How, teacher? I don't understand. Okay, if we have any species from these species, they don't be amphoteric. If we have them in the reaction, they are not amphoteric. But if we have them out of the reaction, they're gonna be amphoteric. Okay, I'll show you, of course, but now, hydrogen carbonate, HCO3. Okay, HCO3 can be CO3 by releasing its second proton or by gaining its previous proton to be H2CO3. Okay, teacher, it can gain or lose its proton, so it's amphoteric. Yeah, it's amphoteric. But in this reaction, HCO3 is what? Okay, HCO3 in this reaction, okay, it gains the proton. It's base only. Okay? So it's base. It's not amphoteric in this reaction. So if we have a previous species out of the reaction, they become amphoteric. But if we have them in the reaction, they don't. They should be acid or base. No more. According to Brunelleschi theory, water is amphoteric because it can react with both acid and bases. We know that, I'm sure about you. Look, water with the acid become a base, water with the base become an acid. Okay, so in here water is base, in here water is an acid. Okay, water is not amphoteric in each of these reactions. We have the reaction, but water out of the reaction, take out water in here. Water is what? It's amphoteric. But put water in the reaction, okay. They will be acid or base, that's all. Not amphoteric in the reaction. Water is amphoteric. But in this reaction, water is acid. In this reaction, water is base. But water only, without the reaction, is amphoteric. In this reaction, look, H2S plus H2O to producing HS and H3O. The amphoteric is, oh, we have the reaction, so we don't have amphoteric. I remember you told me with extremely sure as an extremely sure notification. When we have the reaction, we don't have any amphoteric. Okay, so none of them is amphoteric. Well, it's amphoteric out of the reaction, it's amphoteric out of the reaction, but we have the reaction, so they don't. Okay, they don't. Which of the following is amphoteric? Now, it's amphoteric, it's amphoteric. The right answer is A and B. Well, teacher, why we didn't choose them for this question, but why we choose them in here? Well, in here we have the reaction, so we don't have amphoteric. But in here we have any reaction, so they are amphoteric. Which of the following is amphoteric ion? Oh, we should have amphoteric and it should be charged because of it's specified that it's ion or compound. It's ion. Look, HS. Well, HS is amphoteric. H2O is amphoteric, but HS is ion, H2O is compound. Which of them is amphoteric? Ion. The right answer is HS. HS. Again, Which of the following is amphoteric compound? Oh, we should have amphoteric and compound and neutral charged compound. H is amphoteric, H2 is amphoteric. Well, the right answer is C. No. It's not C. Don't be in a hurry. Wait. Amphoteric compound. It's amphoteric ion. So it don't. H2O is amphoteric compound. The right answer is H2O. Now, acid rain. What is the acid rain? Acid rain. Oh, we heard many things about the acid rain. Especially we are living in Kurdistan, especially in Erbil, mainly, specifically in Erbil, because of Erbil is surrounded by many petroleum companies, mainly Kurmala and Erbil refinery. When they burn the natural gas, it contains almost 5% of H2S, which is too concentrated acid gas or sour gas. And when they burn that gas, it will be raised into the air. And when they meet a drop of water, especially in the winter during the raining season, so they combine with water, they produce the acid, and they return back on our stuffs. So they're going to make many problems. So that's the point about the acid rain. Any gas, well, a gas that contains sulfur, when they combine with water, they will produce H2SO4. Don't forget. For example, SO2. For example, H2S. Oh, they contain our sulfur, so if we mix them with water, they will be H2SO4. Well, it's with water individually, whatever. It doesn't important. If the gas has NO, for example, NO2 or NO3 or N2O5, when they meet a drop of water, they will form HNO3. And carbon, especially CO2 plus water will be carbonic acid, H2CO3. So that's the acid rain, aqueous. When our stuffs mainly things that made up from the iron metal, when they receive this acid rain, they will be in a problem of corrosion, erosion, many things. For example, they affect the fish, okay? They affect the ecosystem. That's why they will make many problems. I'm talking about the acid rain. Okay, write the balance reaction for these chemicals with water. We have SO3 plus water. Okay, it has sulfur, so it will be H2SO4. Well, for you in here, it doesn't matter how many steps it takes. Okay, we only concern with the main product, which is H2SO4. Okay, even I don't want to balance it. H2O plus CO2. Okay, I remember you told me because we have a carbon, so it will be H2C. It will be HCO3. H2O plus N2O5 will be HNO3. So that's the acid rain. So what type of gas cannot dissolve in water? Oxygen. And which one can dissolve in water? Compounds of sulfur, of nitrogen, and of carbon. What about oxygen? O2, no. O2, no. By the way, we have a question. Which of the following cannot dissolve in water that presents in air to produce acid rain? NO2, NO, yeah, they can produce HNO3. CO2 can produce H2CO3. O2, yeah, O2 cannot dissolve in the water. So the right answer is O2. What problem is caused by the acid rain? The acid rain was causing the fish population. Okay? When I say it affects a fish, I mean a fish population. Okay? And it can erode a status bioactivity and the ecosystem can be affected by the acid rain, but actually our book did not mention it, the main problem, okay, which is corrosion problem. They make a corrosion problem especially for the iron. If they meet any iron, they will start to react with the iron slowly until the corrosion problem happens. Now we have hydroxyl group. What is the hydroxyl group? Actually, we've learned about hydroxide group. Look. Hydroxide, but now we have a hydroxyl group. Well, teacher, what's the difference between them? Hydroxide, OH, both are OH. Actually, both contain the same atoms, O and H. But hydroxide, we have in ionic compound base, mainly base. For example, BaOH by 2. It's barium hydroxide, or in amphoteric. In amphoteric it's different actually, but we have something special. We have some exception. Okay. For the hydroxide, IDE, we have hydroxide in the strong base compounds, NaOH, BaOH by 2, CaOH by 2, LiOH, KOH. Okay. But for the hydroxyl group, look, a molecular compound containing OH group can be acidic or amphoteric. This is due to dissolving in water, splitting the bond between O and H. Good. Now, actually, do we have OH only in a base compound? No. In the acids also we have OH group, but what's the difference between them? Why the acid did not yield OH in its aqueous solution, but a base compound can yield OH in its aqueous solution? So that's the point. We're going to learn that thing. Why for strong base aqueous solution we get OH, but why for acid we don't get any OH? However, both of them contain OH group in their formula. But what makes that difference between them? Look, this is phosphoric acid. Actually, we have two OH groups. And this is SO4. We have three OH groups, sorry. For HSO4, we get two OH groups. Oh, teacher, we have two OH groups for a molecule of H2SO4, but why it does not form OH in its aqueous solution? So that's the point. I'll show you why. Look. I'll start by a strong acid, NaOH. Look, NaOH. This is very strong. It's strong. Strong bond. It's weak bond. So which of them can break? Firstly, of course, that one. So when we put strong acid, NaOH, into water, it yields OH. Because of the bond will break in here. Not in here. Why? Because of the bond between hydrogen and oxygen is strong. They can stay together. But about the O and Na, no, it's so weak, so it can break easily. That's why we get OH negative. But for H2SO4, look, H2SO4, well, I'll delete that one. I'll delete. This is O, this is H. Here we have a strong bond. Here we get a weak bond. So which of them can break easily? Well, a weaker. That's why in here we have splitting process. That's why aqueous solution of the acid yields H plus instead of OH. Why? Because of the bond between oxygen and the central molecule, which is mainly non-metal, is so strong. That's why the oxygen stay with the acid, so the only thing that can be released is H plus. But for the base, no, OH can be released completely because of the bond from O and metal is so weak, so it can break. That's the point. Why we don't get OH in the aqueous solution of strong acids, but for base, yeah, we can get. Because of in a base, the bond between OH and a metal is very weak. It can be broken easily, but for the acid, the bond between H and O is very weak, so it can be easily broken to producing H plus. That's the point. And actually, as much we have a consequence, so I'll mention for you. Look, as much as we increase the number of oxygen, the polarity will be increased, the acidity increased. So I'll mention that one, please. We just need 4 minutes to doing that. Look, number of oxygen, okay, number of oxygen. If we increase the number of oxygen, the polarity the polarity will increase. So the bond strength between O and H is weaker bond, stronger acid. Now, if we get more oxygen number, we get stronger acid. Why? Because of we get more polarity, weaker bond. So that's the consequence. Well, using this note, let's answer the following questions. Which of the following has the minimum OH bond? Minimum OH bond polarity, it means minimum number of oxygen, HCl. Which of the following has the most strong or has the most acidity strength? Most acidity strength, it means most polarity, weaker bond, most number of oxygen. So HClO4 is the most stronger. So that's all about the amphoteric compounds and about the acid rain. It's very important. The last subject in chapter 3, it's neutralization reaction. What is the neutralization reaction? Neutralization reaction related to the section 1, chapter 2 extremely. They have a relation between them. We need many informations in your chapter 2, section 1 about the precipitation reaction. We need them. Which compound is soluble, is water soluble, which compound is water insoluble. We need them extremely. Hopefully you remember them. Actually, we do the same that we did for chapter 2, section 1. Neutralization reaction. First of all, let's explain the neutralization, then explain the neutralization reaction. They are two different terms together, neutralization and neutralization reaction. Neutralization, it means reaction between hydronium and hydroxide ion to producing 2 molecules of water. This is neutralization. Okay, neutralization. But teacher, what's the neutralization reaction? The neutralization reaction is the reaction between salt plus acid to producing, it's not salt plus acid, it's base plus acid. Okay, it's base plus acid to producing salt plus H2O, which is water. This is neutralization. It's neutralization reaction. Neutralization is the reaction between hydronium and hydroxide ions producing 2 molecules of water. But neutralization reaction is the reaction between acid and base producing salt and water. Okay. Salt is ionic compound, we know that. Consists of negative and positively charged cation. The anion, the source of anion is the acid. So I'll talk about that one in chapter 4. For now, it's not important. Types of salt. So I will talk about types of salt in chapter 4 because we need them for chapter 7 also. Now, a neutralization reaction is the reaction when the acid and base react together to form water and salt. So that's the rule. Let's take a look about this. Look, when we have acid plus base to producing salt and water, that salt could be water soluble or water insoluble, which is precipitate. We use it as symbol, came from the salt. Okay, if that salt, look, if that salt is water soluble, salt, this is salt, not H. So the positive and negative charge of the salt will be the spectator ions. If we have water soluble salt, so the constituents of that salt become a spectator. Become a spectator, don't forget that. But what if we get water insoluble salt? Water insoluble salt. So there is a precipitation reaction. There is no spectator ions. The net ionic equation is equal to the overall ionic equation. Teacher, what's the overall ionic equation and the net ionic equation? What? Do you forget it? We learned that in chapter 2. But okay, I solved a question and hopefully you remember, but if not, I remind to you how to write them. If we mix aqueous solution of HCl plus NaOH, so write the following points. Formula equation for the reaction or molecular equation, doesn't matter. It means the double displacement reaction. Double displacement. The double displacement reaction. Okay, let's write the double displacement reaction. Na with Cl to producing salt. OH with H to producing H2O. Okay, teacher, we get acid and base together. If we have the reaction between acid and base, it's neutralization reaction. So we should get water and the salt. Okay, it's water and the salt. Let's balance this reaction. We should balance it. Okay. One sodium, one chlorine, hydrogen also is balanced at the same time, and chlorine is balanced also. So this is formula equation. This is double displacement reaction. Then, for overall ionic equation, hopefully you remember that note. All aqueous compounds should be splitted into their, should be splitted into their constituents. Look, HCl, we should split HCl into Cl and H+. But teacher, I remember that you told me H+, it's very reactive, so it will react with water. Look, if we get H+, immediately we should put a molecule of water plus H2O to producing what? H3O. Oh, now H3O came from that H of HCl and Cl. Okay. For Na, we get Na and OH, NaOH. Teacher, now we just fluctuated that balance. We fluctuated that balance. So how we add a water molecule in here? Look in here. So we should add the same molecule for the right side. We have one water plus one will be two. So how many molecules of water do we get in here? It should be multiplied by 2 for the right side. Should be multiplied by 2. This is the rule. But in case of what? Acid reacted with the base. Okay. Now, Na, look, Na and Cl. Okay, what about H2? H2 is a liquid, so it cannot split. It will remain as it is. But what will happen with its coefficient? Okay, teacher, you told me that how many molecules of water do we get in the reactant? We should have the double number for the product. Okay, it's double. Oh, now I understand why we add a water molecule for the right side, because we converted H plus into H3O by ourselves. Okay, now the net ionic equation. The net ionic equation, it's neutralization. What's the neutralization? What was the neutralization? It's the reaction between hydroxide and hydronium to producing two molecules of water. Okay, it's net ionic equation. So we just release it, hydronium and OH and water. What remains? And again, you told me if the salt is water soluble, so the constituent of that salt become a spectator. Okay, we get NaCl. It's aqueous. We know that according to the solubility rules, it's water soluble. So Na plus and Cl negative are spectator ions. You see that? It's very easy. What will happen if that salt, suppose that it's water insoluble? Oh, we should write there is no any spectator ions. So this reaction is equal to the net ionic equation. It means overall ionic equation will be equal to the net ionic equation. Where if we get water insoluble salt. So I'm trying to show you an example that the salt is water insoluble. Okay. For BaOH by 2 plus H2SO4. Okay, BaOH by 2 plus H2SO4. It's important, so be aware about that reaction. BaOH by 2, it's barium hydroxide and H2O. So how we can write the neutralization reaction, the overall ionic equation, the net ionic equation, the spectators, it means ions that just came to see the situation. They are not participate to producing a salt. So neutralization reaction, it means the double displacement reaction. We know that. How to write the double displacement reaction? OH plus H2O, it will produce H2O, Ba with SO4 to producing BaSO4. Well, teacher, now the next step, balancing the reaction. Okay, we should put number 2 in here. 1 Ba, 1 Ba, 1 SO4, 1 SO4. So there's a lack of hydrogen atoms in here. We have 2, in here we have 4. So we should multiply by 2. The oxygen will be balanced by itself after changing the coefficient from 1 to 2. So this is a molecular, exact a molecular reaction, neutralization reaction. Well, teacher, it's about this reaction is about acid by base. So we should get salt and water. Okay. Now, for the overall ionic equation, we should split them. But what type of compound can be split? Oh, teacher, only aqueous. This is aqueous. It's aqueous. No, it's solid. Did you remember about sulfate compounds? Mostly are water soluble except of sulfate ion that combine with barium and strontium and some of them. So let's split them. Ba, we get 2 OH ions, 2 H3O. So we just added 2 molecules of water. So we should increase 2 by 4. Or according to the rule, how many water molecules do we get in this side? 2. So we should have 4 in the right side. BaSO4 remain as it is because there's a strong interaction between barium and sulfate. Oh, teacher, I remember you told me if we have a water insoluble compound, so there will not be any spectator because of the precipitation reaction occurs. In that case, the overall ionic equation is equal to net ionic equation. So it's net ionic equation and overall ionic equation at the same time. The last thing is the reaction between active metal with the acids. Well, hopefully you remember by the starting of chapter 3 when we discussed by the general properties of the acids, we said that acids can react with active metal and their H can be replaced by that metal. Look, active metal reacting with the acid to producing salt plus H2 gas. We have the same situation. If that salt is water soluble, but in here we will have only one spectator. Negative part will be the spectator. Negative part of the acid or negative part of the salt is the spectator. About the positive part, no. Plus H2 gas. What about water? No, we don't have any water. Well, let's solve some example about active metal plus the acid. For example, we have zinc plus HCl. Oh, it's active metal plus acid. So zinc, through the single displacement reaction, can replace the hydrogen atom of the acid. Okay, and it will stay from the place of hydrogen to producing ZnCl2 plus H2 gas, and we should balance the reaction. Okay. Now, ZnCl2 is water soluble. I remember that you told me if the salt is aqueous solution, so the negative part of that salt becomes the spectator. Well, we have ZnCl2. It's positive part, it's negative part. So, the negative part is the spectator. Look, it is spectator, negative part of the salt or negative part of the acid will be the spectator. And the remaining will be the net ionic equation. The only thing that's different from the reaction of the acid with the base is that how many water molecules do we get in here? We should add the same number for the right side. And that's all about the chapter 3. Hopefully you understand about each point. Actually, we escaped some things because of its fast review, its quick review, but we did our best as much as we can, and we're going to continue to stay with you for the next chapters. Inshallah, if we have enough time, we're going to do the same thing for whole of your chemistry grade 12 book. Inshallah, تاواني دعوتو بخواتان دسبيرم خواتان لەگەڵ